Hello everyone, welcome back to Cloud Computing series. In this video, I will solve the important questions from the Unit 4. These 5 are the important questions from Unit 4. Let us start with the first question. Before starting, if you are new to Shiva EduWorld, then subscribe to it for more videos like this. The first question is, explain networking cloud computing with neat diagram. Describe how cloud network supports resource sharing, interoperability and distributed computing. We have to explain networking for cloud computing with a diagram. Here we have a diagram. How to explain in detail. The diagram shows how cloud computing uses networks to connect many users and devices to share the cloud resources. If you observe the diagram, the users and the devices are connected through a network. Clear? Here all users communicate with the cloud through the internet or private networks. Cloud components in the diagram are infrastructure, storage and application. Infrastructure means the physical servers, virtual machines and networking hardware inside the cloud. The storage devices which are centralized data stored in the cloud servers. If you observe, I can see the storage device inside the cloud servers. And the applications are software, services and tools running in the cloud for users. Here we have the applications. And how the network works. Many users using computers, laptops and tablets, mobile phones connected to the cloud. Here if you observe, many users who use the computer, laptop, tablet and mobile which is connected to the cloud. And all these devices send requests over the network. These users will send the request to the network only. After that, the cloud receives the request and process them using infrastructure, storage and the applications and it will send back the output. It will receive the request and process it and send back the output. This allows users to access the service anytime and anywhere. It will receive the request and send back that output. By this, users can easily access the service anytime and anywhere. Clear with this? And they have asked how cloud network supports the resource sharing. Here all users in the diagram are all users will use the same cloud infrastructure and one set of servers and storage is shared by the multiple users at the same time, which means one set of servers and the storage, it will share it by the multiple users at the same time. And virtualization divides the physical servers into many virtual servers, so resources can share it without conflict. And this reduces the cost and improves the efficiency also by virtualization. By this, I can easily say that the cloud network supports the resource sharing. And how cloud network supports the interoperability. The users are using different types of devices, that is PC, tablet and mobile phones. All these devices can still access the cloud because cloud networks are use standard protocols like HTTP, APIs and TCP/IP. Irrespective of the device the users use, they can easily access whatever they want at any time. Clear? And this allows different applications and platforms to communicate smoothly. By this, the cloud network supports interoperability. And how cloud network supports distributed computing. Behind the cloud icon, multiple servers are shown working together. Here, multiple servers works at the same time and the tasks are divided among these servers and the network connects these servers so work can be processed in parallel. Clear? This increases the speed, reliability and scalability of the cloud services. Whatever the servers I have, those servers will work parallelly, so that I can easily say cloud network supports the distributed computing, which increases the speed, reliability, scalability of the cloud services. And the next question is, describe the data center environment used in the cloud computing. Explain its components such as servers, racks and cooling systems, power system and data center network architecture. Here the data center environment is a specially designed facility where the cloud computing resource like servers, storage, networking devices are installed. Not only installed, they can manage easily and operated smoothly. Clear? And it provides the physical and technical infrastructure needed to run cloud services efficiently and continuously. This is the data center and the main components are, as I told, the servers, racks, cooling systems, power system and data center network architecture. The server means these are the powerful components that run the cloud applications, virtual machines and store the user data as well. Clear? This is all about the server. They perform processing, computing and storage operations required for the cloud service. Servers will store the user data and whenever I want to access, I can easily access by requesting to the servers. Clear? And the racks means it holds multiple servers in a vertical structure to save the space. It will store the multiple servers in a vertical structure to save the space. And racks means I can easily say the racks. What is racks? By the name, you can easily understand it is a multiple servers in a vertical structure to save the space. Each rack organizes the servers neatly and switches, cables and storage devices neatly. It will organize the servers, switches and cables and the storage devices neatly, making management and maintenance easier. For that purpose, I will use the racks. It has the switches, servers, cables and storage devices which are organized in perfect manner. And cooling system means data centers generate a lot of heat due to thousands of running servers. It will generate lot of heat due to thousands of running servers at the same time. And cooling systems like air conditioner, chillers and ventilation units maintain the temperature and prevents the equipment from the overheating. It will prevent overheating. Okay, clear? Because multiple thousands of servers run at the same time and the heat will also very high. To cool that down, we use cooling system. And power system, these provides continuous electricity to the data center. The power system will send continuous electricity to the data centers, and they include UPS, generators, power distribution units, and the backup batteries to ensure cloud services do not stop even during power failures. Even if there any power failure also, it should not stop. It has to work continuously. For that, the backup batteries also are there. And the data center network architecture, here it connects the servers, storage devices, and users through high-speed switches and the routers. Clear? This is the data center network architecture. The common architecture includes three-tier architecture, that is core, aggregation, and access layer we have in the three-tier architecture. In leaf spine architecture for low latency and high scalability. And this network architecture supports fast data transfer. The data transfer is very fast, and load balancing and communication between server and cloud users. In short, I'll explain once again. The data center is a backbone of the cloud computing. It contains servers, racks, cooling, power, and a strong network architecture as well. These components together ensures the continuous, scalable, and reliable cloud services. Clear about this? Let us move to the next question. What are the major networking issues in data centers? Explain the problems related to bandwidth, latency, traffic congestion, scalability, VM migration, and energy efficiency. Here, the major networking issues in data centers are bandwidth, latency, traffic congestion, scalability. They have explained, they have told you, right? These are the major networking issues. Data center handles huge amounts of data and communication between thousands of servers, as I told you. Because of this, several networking issues arise that affect performance and reliability. Here, the network issue will affect the performance and reliability. The major networking issues are bandwidth problem, which means data center require higher bandwidth to transfer large volume of data. If I want to transfer any large volume of data, then it requires high bandwidth only. When the available bandwidth is low, data transfer becomes slow. If I have the bandwidth very low, then the data transfer will be very slow. Applications take more time to respond. If it is slow, obviously it will take more time than the expected, and overall cloud performance drops. Here the cloud performance drops automatically. This is about the bandwidth problem. And latency means it is the delay in sending or receiving the data. If I want to send or receive any data, the delay, that is a latency. The delay in sending or receiving the data is called latency. And in data centers, latency increases due to long communication paths. If the communication path is very long, then the latency is increased. Overload switches or slow links. If the link is working very slow, that is also path for the latency, increase in the latency. High latency affects the real-time applications like video streaming or online services. It will affect the high latency will affect real-time applications like video streaming, live video streaming, or online services as well. Traffic congestion. When too many servers exchange the data at the same time, network links becomes congested, and this causes the packet delays, packet loss, and transmission, retransmission, and reduced throughput. This is whenever too many servers exchange the data from one server to another server at the same time, the traffic congestion will happen. This is also a major issue of the networking. And the next one is scalability issue. At the number of users and servers increase, when the number of users and servers both will increase, the data center network must be grow, which means it has to be big. And traditional hierarchical network becomes difficult to expand and may not handle the growing traffic efficiently. When the users and servers increase, it has to grow, or else it will be a very big problem, the scalability issue. And the next one is VM migration issue, the virtual migration issue, virtual machine. When virtual machine is moved from one server to another, large amount of data must be transferred, which means when VM is moving from one server to another, the large data has to transfer. This increases the network load temporarily and can cause the delays, because the large amount of data transferred from one server to another server, and it can cause the server delays, congestion, or the service interruptions if the network is not optimized. This is the major drawback and the issue faced in the networking. And energy efficiency. Networking devices like switches, routers, and the cooling system consumes a lot of power. As I told you earlier, poorly designed networks waste the lot of energy here and increase the cost as well, cause more heat, and which further increase cooling requirements, which here the cooling requirements are needed when the lot of heat is generated. In short, I'll explain once again. Data centers face networking issues like bandwidth, high latency, and congestion. Scalability becomes difficult as data centers grow. And VM migration adds extra load to the network, and high power consumption affects energy efficiency and cost, and needs cooling requirements also. And the next question is explain transport layer issue in data center network. Transport layer issues, and discuss the TCP performance problem, flow control, congestion control, challenges, and solutions used in the cloud data centers. The transport layer in data center network is responsible for reliable data delivery between servers, which means I use the transfer layer for better data delivery. Clear? Between the servers. The most data centers use TCP, but TCP was originally designed for the internet, not for high-speed data center environments. The TCP, Transmission Control Protocol, it used in the most data centers, but it is originally designed for internet and not for the high-speed data center environments. Because of this, it faces several issues. Because of the TCP only, it will face several issues because it is use it here, but it is not supposed to use it. Transport layer issues in TCP performance problems. Here TCP assumes that packet loss is caused by network congestion. However, in data centers, packet loss may happen due to short bursts of traffic or buffer overflows. This makes TCP unnecessarily slow and reduces the performance. This is the TCP performance problems. And flow control issues are flow control manages how fast the data is sent, and in data center servers produces the data at very high speeds. If the receiving servers cannot process the data that fast, buffer overflow and causing the delays in the packet drops. For example, if it is sending the data too fastly but it is taking time to process it, the servers is taking time to process it, it will buffer will overflow and causing the delays and packet drops. This is the flow control issues. And congestion control challenges are data centers have many short flows and long flows. TCP threads all flow the same, causing unfair bandwidth sharing, high delays for the short flows and burst traffic and congestion. If it is short flow or long flow, it treat all the flows same. That's why the unfair bandwidth sharing, high delays for the short flows also, and burstly traffic and congestion will happen. This is the congestion control challenge. Packet loss and queuing delays reduces the efficiency also. And the next one is they have asked to explain the solutions used in cloud data centers, that is DC TCP, that is data center TCP. It improves the TCP by using ECN, which means explicit congestion notification. By using this, instead of waiting for packet loss, switches mark packets when queues begin to fill, and this helps to control the congestion early. And the second, TCP offloading and RDMA. The techniques like bypass TCP for faster data transfer with the low latency. With the low latency only, I can easily transfer the data fastly. Here the RDMA means remote direct memory access. Load balancing. Traffic is distributed across multiple paths using technologies like equal cost multiple path, reducing the congestion. By using this, I can easily solve that problem. And traffic engineering. It will separate the short flows and long flows and giving priority to short flows to reduce the delays and improve the application performance. Before it was taking the same for the both short and long flows and delay for the short flows. But here it will separate the long and short flows, giving priority to short flows and reduce the delay for that and improve the application performance as well, which is the best solution for that. And here TCP struggles in data centers due to high speed and bursty traffic. Flow control and congestion control faces the delay, packet loss and unfair bandwidth as well. The solutions are DC, TCP, RDMA, load balancing and traffic engineering. These are all the solutions for these issues. And the next question is, write short notes on major cloud service providers, compare Amazon Web Service, that is AWS, Microsoft Azure and Google Cloud in terms of services, pricing models, networking features and global infrastructure. The short note on major cloud service providers are Microsoft Azure, Google Cloud Platform and Amazon Web Service. Microsoft Azure means it is best for enterprise and business solutions. It works smoothly with the Windows, Office 365 and Active Directory. It provides a virtual machine, that is VM, databases and cloud apps as well. It is strong in hybrid cloud, which means on-premise and cloud. Hybrid cloud means which has the private and public cloud, combination of both, and it is preferred by companies already using Microsoft tools. The companies which are using the Microsoft tools already, it prefers those companies. And Google Cloud Platform, that is GCP, the strongest in AI, ML and big data technologies. It is the strongest in the AI, ML, big data technologies and uses Google's global fiber network for low latency, and it provides the powerful tools like BigQuery and Kubernetes. Provides the powerful tools like BigQuery and Kubernetes, easy to use and developer friendly. Which is developer friendly? It is best for data analytics, research and high performance computing. For these things, it is very best platform. And the next one is Amazon Web Services, that is AWS, the largest cloud platform with the wide service variety. This is the largest cloud platform and with wide service varieties are, and it offers EC2 for computing. EC2 means elastic compute cloud and S3 means simple storage service for the storage purpose. Strong support for AI analytics and serverless. It gives the strong support for AI analytics and serverless, very reliable with huge global infrastructure, and it is suitable for all types of cloud applications. This is all about the Amazon Web Services. They have asked to explain the differences of AWS, Microsoft Azure and Google Cloud in terms of service offered, price models, networking features and global infrastructure. Let us see. This is largest set of services like EC2, S3. For storage, I have S3 and Lambda, AI and IoT also. These are all the services offered from AWS. In Microsoft Azure, it is strong enterprise apps, virtual machines, databases and Microsoft integration. These are all the services offered from Microsoft Azure. From Google Cloud, it is best for AI, ML, data analytics, Kubernetes and big data tools. And here the pricing models are pay as you use only. How much ever you use, you have to pay for only that. And reserved instances, spot instances. Here also pay as you use only. Reserved instances, hybrid benefits for Windows. It is also same, pay as you use, Sustained use discounts are there. Committed use discounts also are there. The networking features are VPC, Elastic Load Balancing, and Global Accelerator. Here we have VNet, Load Balancer, and Express Route. In the Google Cloud, we have Global VPC, Google's Global Fiber Network, Low Latency, and Load Balancing also. The global infrastructure is the largest number of regions and availability zones are there for AWS. For Microsoft Azure, very wide enterprise focused global presence, and here it uses Google's private global network for high speed and low latency. And the security and compliances are high mature security tools and wide-edge compliance certifications are. Here strong identity management with a active directory, zero trust model, built-in encryption, very strong security. Here Google Cloud is very strong security. Here powerful but slightly complex for the beginners. AWS is very powerful but little complex for the beginners. Here it is very easy for the enterprise already using Microsoft tools. Who are using the Microsoft tools, for them it is very easy. It is very simple interface, developer friendly and easy to learn, which is Google Cloud. It is all about the Unit 4 of cloud computing. Here completes the Unit 4. If you found this video helpful, then subscribe to Shiva EduWorld for more videos like this and share this video with who are struggling in cloud computing. Thank you very much for watching. If you want me to explain any particular subject or topic, comment below and let me know. Thank you for watching. See you in the Unit 5 video.